Hi everyone. So welcome to this session. I'm going to bring some new variety into our experience by taking a problem from electromagnetic, and the topic is transmission line, right? So this question was asked in GATE 2024. I just want to show you that how to solve question based on transmission line, right? So you know that whenever the question is given in the GATE examination, that will be highly intuitive. If you have studied a basic concept, then you can easily solve that question, and if it is 1 mark question, then you can solve that question very faster, right? So I'm just going to show you how to solve this kind of question very faster, right? So let me show you the question. This question was asked and it was asked for 1 mark, you can say. And consider a lossless transmission line terminated with a short circuit. So they have already mentioned that the transmission line has got short circuited, right? I mean, okay, that has been terminated by short circuit with a shown in figure below. As one moves toward the generator, so this is the load here, you can say, and you have to move in this direction. That is nothing but a generator side. Okay, so in transmission line, always one will be the generator side, one is gonna be the load side, where the load is gets load gets terminated here by short circuit. Okay. uh, Next is what they're asking is, as one moves toward the generator from the load, the normalized impedance is nothing but Z in A, Z in B, Z in C, Z in D. What is the meaning of normalized impedance? As we have studied in our classroom, normalized impedance is nothing but the impedance which is divided by, you can divide by what? The characteristic impedance. Let's say that there is let's say this is nothing but your ZL. Okay, and you're trying to find here Z in, you can say, right? This is Z in and this is ZL, you can say, right? So if you're trying to find Z in, and if you got Z in and divide Z in by Z naught, okay, so that will become Z in, you can say, bar. That is a normalized impedance. Z naught is going to be a characteristic impedance. In this question, they haven't mentioned the characteristic impedance. It means you have to divide. Okay, so these Z in A, okay, again notice here Z in A, Z in B, okay, Z in C, Z in D. These are the impedances that you have to find out at different point on the transmission line as you move from load to generator. It's a very simple situation, right? And they have given these lines, like if you look at the movement, right? Lambda by 8 movement, then again lambda by 8 movement, then again lambda by 8 movement. Okay, so let's say you are starting from load 2 and you moved lambda by 8, right? Okay, so what will be the value of Z in A? Since this is a short circuit, okay, so short circuited transmission line, you can say that load has been terminated by short circuited. Okay, so what is going to be the value of Z in? Okay, so we can think about it. Already we have studied. Let's say this is a transmission line and you have terminated this with the short circuited. So what is going to be Z in here? Let me first find out Z in. And this is nothing but Z naught. So Z in is directly you can find out. I mean, you should be also keeping in mind that will be J Z naught 10 beta L, right? As it is a lossless transmission line, so there will not be hyperbolic kind of 10 hyperbolic or kind of thing, right? You always have to choose like this, JZ not 10 beta L. Now beta L is nothing but electrical length. L is given. This transmission line is nothing but what? Lambda by 8, right? Lambda by 8. Okay, so after finding this itself, you can get the answer. You don't have to waste your time. So you know that JZ naught 10 beta is 2 pi by lambda into lambda by 8, right? So this will be JZ naught only. Okay, this is Z in. Okay, you can say Z in A. Now you just take this Z naught, divide by Z naught. Okay, that will be plus J. Okay, plus J1, you can say. So that is the normalized impedance that you got. Okay, once you move lambda by 8 from load to generator. Okay, load to generator side. But make sure that you can also keep in mind. Okay, let's say load is terminated by short circuited and you're moving lambda by 8 distance. Okay, lambda by 8 movement is there. It means inductive nature will be the, okay, impedance will be having inductive nature, you can say plus J. Okay, plus J Z naught. Okay, and after next lambda by 2, it will be capacitive nature. So lambda by 8, lambda by 8. Okay, keep in mind this. Okay, so can we have the option look now? Yeah. So Z in A should be plus J1, right? So this option is gone, this option is gone, this option is gone. Only option A is correct. So in fact, in this question, you don't have to solve it, right? Okay, but you can think about it. You see here lambda by 8, lambda by 8. What is lambda by 8 plus lambda by 8? That is 2 lambda by 8, which is lambda by 4. Okay, that we have like an inverter. Okay, lambda by 4 transmission line, let me recall that also. See, lambda by 8 plus lambda by 8, that becomes lambda by 2 lambda by 8, that is lambda by 4 only, right? So if you recall lambda by 4 transmission line, if it is terminated by the short circuit, what is going to be this value? You can say Z in B, right? So Z in B is going to be again J Z naught 10 to pi by lambda and lambda by 8. Okay, though we already got the answer, but just want to show you, right? So this is how we transform impedance. We transform load impedance to input impedance, right? So we are trying to find the input impedance of the transmission line at different points, right? So you see this is lambda lambda gone, and this is lambda by this is 2. Okay, again please remember that. Okay, I hope this makes sense. So this becomes jz naught, okay, 10. And what is this? You can see here, okay, that lambda lambda gone, right? And 2, this 2, okay, that is 4, and 4 twos are, right? So it becomes pi by 2, which is nothing but infinity. Okay. So how does it behaves? Lambda by 4 transmission line behaves like a what? Inverter, right? You can see here, this is load is 0 here, okay, but this impedance is infinite. Okay, understand? So you can say the normalized impedance must be infinite. Okay, inverter की तरह काम करता है. Lambda by 4 line is nothing but inverter. Okay, lambda by 2 is nothing but what? It is going to repeat. Okay, let's say your load is 0, short circuited, so your input will also be, you can say, short circuited. I mean, you will get the input impedance or normalized input impedance as 0 only. Okay, please remember. So it is going to behave like a inverter, and it is going to repeat the same impedance. I'm just going to show you, right? So if you add all, let's say we are trying to compute this. See, z in B will be infinite. Okay, so this option is wrong, this option is wrong, but this option is correct here, right? Okay, now let's say we want to find at this point, that is z equal to minus L, and one end is short circuited. Lambda by 8, lambda by 8, lambda by 8, lambda by 8, that is 4 lambda by 8. What is 4 lambda by 8? 4 lambda by 8, 4 times lambda by 8, which is nothing but lambda by 2. And lambda by 2 line, let's say this is short circuited, and what is going to be this? Z in, you can say, D will be 0 only. Simple. So Z in D should be 0, right? So 0, this is wrong, this is wrong. Okay, yeah, this is also wrong, because naturally it is wrong only. So how simple this question was, right? Let's say we have unknown length transmission line. We don't know lambda by 4, lambda by 8, okay, these kind of a line. So what we can say here, and this is nothing but your load ZL, and this is Z naught, and this is the length of the transmission line, and we say that this is Z equal to 0, this is Z equal to minus L. If you are moving from, you can say, source to load to generator side. Okay, so what is Z in here? So Z in is nothing but what? How to write that? Z naught, okay, Z naught ZL plus JZ naught 10 beta L. I'm talking about lossless transmission line. Lossless transmission line. Always in the exam, in gate examination, they will be asking you to compute lossless transmission. They will be asking you to handle lossless transmission line. Z naught से start करना है, then ZL plus JZ naught 10 beta L upon Z naught plus JZL 10 beta L. Okay, you can think like that. So if ZL is 0, let's say ZL is 0, it means short circuited. So this will be 0 here, right? And this will be 0. Understand? And then they will be cancelling. So you will get here what Zn is going to be equal to, that is called short circuit input impedance. That is nothing but, okay, this is short circuited transmission line. Then load is terminated by short circuited. It will be JZ0 10 beta L. And let's say that if ZL is open circuited, that is infinite. Open circuited means infinite. So Zin is going to be what? Z0 start with ZL plus JZ0 10 beta L upon, then you write Z0 plus JZL 10 beta L. Okay. Now, since they have given ZL is infinite, okay, so we can't plug infinity directly. You just take ZL, common. So ZL common ले लिया. So 1 plus, J Z0 ZL 10 beta L upon J, ZL common. So it will be ZL plus J 10 beta L. Okay. Now you can plug, just ZL cancel. Now you plug ZL equal to infinity. So this will become 0 and this will become 0. Okay. कितना आ जाएगा Z0, okay, and then upon this will be J 10 beta L. What is this? You can compute this. This is nothing but minus J Z0 cot beta L. Okay. So if someone is going to ask you what is the let's say load is short circuited, what is going to be Z in, okay, short circuited, that is nothing but JZ0 plus JZ0 10 beta L, right? Please remember that length can be anything. Length of the transmission line can be anything. It can be lambda by 8, lambda by 4, lambda by 2. These are nothing but the standard length of the transmission line that you should know, okay, before you go for the examination. Okay. And if your transmission line is having Z naught and it is open circuited here, right, then what is going to be Z in? So we call it Z in OC, right, open circuited input impedance. That is going to be what? Minus J Z naught cot beta L. And these formulas are only valid when your transmission line is lossless transmission line. Okay, lossless transmission line. Now if you take the product of these two, right, like short circuited uh, impedance and open circuit impedance, if you try to take the dot product of this, so what are you going to get? Can we have? Yes, that is the very useful result. So if you're going to take the dot product, you can say I just want to check ZSC times ZOC is going to be what? Plus J, let me, okay, that will be very useful result. Okay, many questions are asked nowadays, so it will be nothing but J Z naught 10 beta L times minus J Z naught cot beta L. Okay. J times minus J, which is nothing but what? Minus J square, that is 1, right? And 10 beta L times cot beta L is 1 only, right? So here we will get Z naught square. Okay. So you can say that, let's say we have got short circuited impedance as well as open circuit impedance of the transmission line. Okay. So we can find out the what? We can find out the characteristic impedance just by taking their geometric mean. So Z naught is going to be square root of geometric mean. That is, you see, this is very useful result. Okay, useful. You will find many questions from this topic also. Okay. So this question was very intuitive and very easy, right? Anybody can solve it. Okay. Please remember that. And as I told you that uh, as lambda by 4 from the short, okay, the impedance is going to transform as infinite. Okay. Inverter की तरह काम करेगा. And if you are going to increment lambda by 8, okay, let's say lambda by 8 up move kiye, so your impedance is going to be inductive, and your okay, if you're going to move lambda by 8, lambda by 8, lambda by 8, so again it is going to be capacitive. Okay, I hope this makes sense. So if you look at this option, so option option A is gonna be correct here. See, this is plus, this is infinite, because at this point if you try to compute lambda by 8 plus lambda by 8, that is lambda by 4 only. So at this point infinity हो जाएगा, ये plus j हो जाएगा, and this is minus j. Okay, this is minus j. Okay, this is plus j, this is minus j, and this is 0. So this should be lambda by 8, lambda by 8, so you can say 0 here. Okay, I hope this makes sense. I mean, you have to come from here with respect to load, you have to find, right? So lambda by 8 plus lambda by 8 plus lambda by 8 plus lambda by 8. Okay, and here it is minus j. So lambda by 8 plus lambda by 8 plus lambda by 8, that is 3 lambda by 8, and 3 lambda by 8 gives you minus j. Okay, please remember that. देखो, let's say that this is 3 lambda by 8. Okay, and it is short circuited and you want to find z in something, so it will be nothing but what, plus j z naught. See, normalize, when they say you have to take z naught down. Okay, z in by z naught, try to divide the transform impedance by z naught, and this is 2 pi by lambda into 3 lambda by 8. Okay, so just lambda lambda gone, and this is 2 by 2 by 4, so which is plus j z naught, 10 3 pi by 4, right? Pi by 4 is 1, right? So you can write this as plus j z naught, 10 pi minus pi by 4. Okay, so this will be nothing but minus j z naught. So this is how you can think. Okay, and it's a very easy. So odd multiples of lambda by 8, it means it is gonna give you minus j, and okay, so this is how we can find out the answer very quickly. The option A was correct. Thank you. We will meet in the next session.